Welcome to ITP132 C++ Programming 1. This chapter introduces most of the basic elements of C++: types, variables, expressions, statements, and functions. Along the way, we'll briefly explain how to compile and execute a program. After having read this chapter and worked through the exercises, you should be able to write, compile, and execute simple programs. Later chapters will assume that you can use the features introduced in this chapter and will explain these features in more detail. The way to learn a new programming language is to write programs. In this chapter, we'll write a program to solve a simple problem for a bookstore. Our store keeps a file of transactions, each of which records the sale of one or more copies of a single book. Each transaction contains three data elements. The first element is an ISBN, International Standard Book Number, which is a unique book identifier. The second is the number of copies sold, and the last is the price at which each of these copies was sold. From time to time, the bookstore owner reads this file and for each book computes the number of copies sold, the total revenue from that book, and the average sales price. To be able to write this program, we need to cover a few basic C++ features. In addition, we'll need to know how to compile and execute a program. Although we haven't yet designed our program, it's easy to see that it must define variables, do input and output, use a data structure to hold the data, test whether two records have the same ISBN, contain a loop that will process every record in the transaction file. We'll start by reviewing how to solve these subproblems in C++ and then write our bookstore program. Every C++ program contains one or more functions, one of which must be named main. The operating system runs a C++ program by calling main. Here is a simple version of main that does nothing but return a value to the operating system. A function definition has four elements: a return type, a function name, a parameter list, could be empty, enclosed in parentheses, and a function body. Although main is special in some ways, we define main the same way we define any other function. In this example, main has an empty list of parameters. In this example, main has an empty list of parameters. The main function is required to have a return type of int, which is this one. The return type. The int type is a built-in type which stands for integer, which means that it is one of the types the language defines. The final part of a function definition, the function body. It's a block of statements starting with an open curly braces and ending with a closed curly braces. The only statement in this block is a return. Which is a statement that terminates a function. As is the case here, a return can also send a value back to the function's caller. Whenever system calls this function, the return statement, it will define whenever where actually this function will end. So we can also count the return statement as the function terminator. In this case, the return type of main is integer and the return value is 0, which is also an integer. If we wanted to define this function as something else rather than integer, like float, then we would have to write 0.0 rather than just 0. So whatever is going to be our return type of the function, we have to return that particular data type whenever we are going to terminate the function. Note the semicolon at the end of the return statement, which is here. Semicolons mark the end of most statements in C++. They are easy to overlook, but when forgotten can lead to mysterious compiler error messages. Normally, we will observe a syntactical error if we miss a semicolon, but there could be some other errors which are observed too if we miss a semicolon inside of our function statement. On most systems, the value returned from main is a status indicator. A return value of 0 indicates success. A non-zero return has a meaning that is defined by the system. Ordinarily, a non-zero return indicates what kind of error occurred. So if we return 0, that means success. If we return something other than 0, for example, like 1, maybe 2, 3, this could tell the system that something went wrong. So this return code will have its own meaning. So the key concept here is types. Types are one of the most fundamental concepts in programming and a concept that we will come back to over and over in this chapter and in this course. A type defines both the contents of a data element and the operations that are possible on those data. The data our programs manipulate are stored in variables, and every variable has a type. When the type of a variable named v is t, we often say that v has type t, or interchangeably that v is a t. For example, if we say, excuse me, if we say variable age is integer, then we can also say integer age has type integer, or interchangeably that age is an integer.